All right, here we have data in the normal distribution or normal distribution. So let's talk about this. It's just going to show like different curves and data sets on graphing lines, all that fun stuff, normal data sets on tables. So let's check it out and see. Warm up question. Okay, bar graph shaped like a bell. You'll hear this a lot. Bell curves, meaning that starts off small on each side, kind of curves up like a bell and goes down, or kind of like an upside down U or something like that. You'll see that a lot. Okay, so let's read more about normal distribution. It's a data distribution that's symmetric, has a bell curve, so shaped like a bell, shaped like an upside down U. The mean, sum of all the values in the data set, divided by the total number of values. So you'll see kind of things distributed like this, like weight, height, heart rate, blood pressure, IQ. You'll see it kind of on a curve. So typically it says that you want to aim to be like on the lower end of the spectrum, like where not necessarily lower end, but depending on what it is, of course. Or like somewhere right in the middle. So here, like right now, we have mean, median, and mode, kind of right in the middle. Depending on the numbers, like sometimes it's good to be on the lower end. If, like, say, for blood pressure, your blood pressure, you want it to be a little bit normal or on the lower side. IQ, like IQ, typically, if you have a higher IQ, it's usually better than a lower IQ. So it's something like along those lines, like. So continue with probability distribution. The probability distribution for a continuous variable, which can take on any value. Now we have probability distribution, distribution of the values in a data set that it reveals the probability of each data value occurring. Okay. Median, middle number, like right in the middle of number. Or like another example, like with bell curve, say like middle of the row is like a C average, and then like here's the A average. So like if you want higher grades, like it's good to be on that end, like the higher end for like the A average, but C average is usually like right in the middle. It's just like it's just how curves like the bell curve is shown. Like isn't nothing is ever like perfect or like set in stone. And this just gives you like a couple more examples. So like if you struggle coming up with real world events, like think of some of your own events. Now I've given you a few examples already. Now think if you can come up with something else as well. But then again, there's nothing perfect and there's no perfect distribution in the world either. But standard deviation is usually the measure of variability in the data set that describes how far away each data point is from the mean. Means the middle number right here. Standard deviation indicates where like the number is and how far away it is. So here's just some other curves and some other examples. Probability curve. This just gives you examples, like kind of play around with it. Let's see if we do this. We can move the curve over here, depending on where we put it on the graph. This shows you here, we're going to make the curve really tall, or you shrink it down like this. So this is just a good tool if you want to play around with probability curves and just kind of learn a couple of things. Here's some examples of some other graphs and some norms here. And you can do that on this as well. This just shows you with the standard deviation, you'll have, let's see, 68% in between here. So in the middle, 34 on each side, because 34 plus 34 is 68. Then you have 13.5% on these sides in the yellow, and that equals 95% of whatever you are measuring. And then 2.35 is the purple on each side, and that represents 99.7%. And then the other, like 0.3, is just somewhere floating around over here. And this just shows like the 68, 95, 99.7 rule, where all the data will fall. 68% is right in the middle, right there in the blue. 95% is yellow and blue. And then 99.7 is all three colors. Pretty interesting. Now, which of the following statements about normal distribution is false? 50% of the area lies within 2 standard deviations of the mean. False, because it's actually 68, not 50. All right, here's just some other examples. Skewed right means obviously majority of the data is pointing on a different side. That means it's skewed right when, so interesting though, majority of the data, when it's skewed right, is pointing on the left side. And you're probably going to guess it because skewed left means that the majority of the data is pointing on the right side. So think skewed left to the right, skewed right to the left. Weird, opposite, but true, as you can see on the graph. All right, we'll skip the question. Simulation, you can watch that video on your own. Skip the question for you to do on your own. Inferential statistics, a process for making inferences about population parameters based on data collected from a random sample of the population. And this just shows here's where the data is going to fall. 68% right here. Questions, let me do the questions on your own. And this just shows here 68% is going to fall in the middle. Here's another percentage that they're calculating this percentage of data right here. Okay, so how is it scored? How many scored between 75 and 90? Right here, we can tell this is 95% because this many people fell in this range. And because they're falling in this range, meaning that there's 95% scoring right here. How many scored below? We'll measure the data right here. 34% is that one part, like the yellow shaded part. And then the rest, about 50%. How many scored above 90? Well, again, it's about 50-ish percent. And then how many scored below? And there you have it. We have quite a bit that scored below 90. So you can measure like the good majority of it. And we'll review these. So this is how it's being measured here. So 68% are scoring between 75 and 80. And then 95% scored between 70 and 90. So it says that because the curve is symmetrical, we can add half of 68 to the 95%, which is 47.5%. So how they're figuring it down, they're breaking it down even more, and they're figuring that this is the percentage that, so if you are falling between 75 and 90, it'll be about 47.5% because you have this portion here, the 68 here, but you don't have the other side. Now this would be 95% if you're going between 70 and 90. Now we take away just the other part of it right there. Again, this one. But it says if we know that 68% of the data is between 75 and 80, and then we know 50% scored below 80. So because the curve is symmetrical, you can subtract the half of 68 or 34 from the 50%. So you have the 50% right here, 50% scored below a certain point right here. So 50% are scoring below or between 75 and 80. So then we can conclude the number that's scored below 75 is going to be this percentage right here. Same concept over here, which scored above 90. So we have the 50% here. 50% again are scoring between above 80. So like 80 and above. So you have 50% right here. Then you break it down even further. And then you have, let's see, we have 90% right here. So scored above 90. So we just have a small little portion right here. It can get a little confusing when you're looking at those graphs. And basically, like, you just have to read like just a little bit more of it. Sometimes looking at the graph, we can say, okay, sure, here's the 95%, but we have to break it down just a little bit further. Z-score found by subtracting the mean from a particular data value and by dividing the standard deviation, which gives the number of standard deviations, the data value from the mean. Okay, this shows another example, giving you the z-scores. Now you'll see z-scores a lot too when you are doing standard deviation, and this just kind of breaks down some of the formula and just gives you like a little bit more information. Well, if you do this on your own, this standard table gives you some more information about z-scores. Here's another example. More information about z-scores. Here's a whole long table of your z-scores. Now you have, this is to the left, and we have two, whoops, to the left, so left values of the z-score. That'll come in handy answering some of the questions as well. Okay, and then we'll skip this, have you do this stuff on your own as well. Z-scores, this just talks about z-scores, and it's just breaking down the formula just a little bit for you. You do the questions on your own. And hopefully that clears it up and just gives you a good understanding, and I hope you enjoyed.